Given that y equals the absolute value of x squared plus 6x minus 16, we need to find the range of possible values of y if the equation has different numbers of roots. You can solve this problem using the quadratic formula and inequality, but we will demonstrate a simpler method this time. First, we want to complete the square within the absolute value signs. You might recall from binomial expansion that the sum of a and b raised to the power of 2 is expanded into a squared plus 2ab plus b squared. We can see that 6x in the given expression is equal to 2 times 3 times x. This means that the square can be completed by rewriting the expression into x squared plus 6x plus 9 minus 25. So this will give us x plus 3 raised to the power of 2 minus 25. For now, let's just call this uppercase y. And our next step is to sketch a graph for it. We can tell it is a parabola that opens upward, and the coordinate of its vertex is at minus 3, minus 25. Normally, to draw a curve, you need to determine the roots as well, such that you will know where on the x-axis the curve will intersect. But for this question, it is actually not really required, as you will see in a minute. The important thing here is to recognize that a portion of the parabola is underneath the x-axis. So if we were to sketch a graph for the given y that has the absolute value signs on, we will have to flip everything below the x-axis to above, because the absolute value signs makes everything positive. The point that mirrors the vertex of the uppercase y would be minus 3, 25. Now we can determine the possible values of y. All we have to do is to draw a horizontal straight line across the plot. The number of roots will be equal to the number of intersections this straight line has with the curve of y. So if we start from above, where y is greater than 25, immediately we will see that they will have two intersections. So this is where it has two distinct roots. And if we move the straight line downward, the number of intersections becomes 3. This is where y equals 25, and also the only place where there can be 3 distinct roots. Because once we move further down, we will end up with 4 intersections. And once we touch the x-axis, the number of intersections changes from 4 to 2. So the possible values of y for 2 distinct roots are not only y greater than 25, but also y equals 0. So finally, once we move into the negative half of the y-axis, there will no longer be any more intersection. So this is where there will be no real root.